Hey everyone, welcome to CDCon. I'm Hibri and this is my colleague Ruchir. Um, we are here to talk about scaling cloud adoption while building a world-class developer experience. I'm Hibri. I work for Contino as a principal consultant, and I like the challenge of using public cloud and continuous delivery to help teams deliver at a sustainable pace. I also like using systems thinking to navigate the challenges of complexity.
Hey everyone, Rashir here, account principal at Contino. So I love building great teams to enable engineering culture. I have a real passion for developer experience and particularly how that can help accelerate public cloud adoption, and that helps best teams adapt. Of lean, advocate for sort of best engineering practices and enabling transformation with the DevOps, Agile, and a lean approach. So what is DevX? So developer experience really is forcing the organization almost to think of it from a developer-centric perspective, a point of view, to focus on what the developer journey is to optimize software delivery and ultimately tackle productivity. So how can you go from ideation to design to testing to into production, but from a lens or point of view of a developer. Um, and really what that means is, the notion of, look, Ma, no hands, right? It's enabling your developers within your organizations to be able to cycle on their own. And that could relate to a whole bunch of underlying capabilities that you can enable as part of your enterprise. So as a developer, I want to be asking questions like, can I independently build, version, deploy, and release my code? Is there a definition of done that the entire team is creating? Do I have dedicated Scrum master in my feature team to inspect, adopt, and adhere to agile values? Is there a visibility in terms of DORA metrics that allows us to capture throughput and stability? These are all, these capabilities, the underlying capabilities that should be at disposal for a developer to really learn and understand and enable their journey throughout this SDLC in place. So, who are the devs in the developer experience, you might ask? Really, it's the question back is, is as a developer, are you the person who's building the platform? Are you a person, who's building on top of that platform, i.e. different layers? You might be operating that platform and just interacting with it, or you might be, building and running and owning things on the platform. And all of those people, if it's a yes, then you're a developer for it. And your part and your experience as part of the interaction within that platform counts heavily towards what the end outcome and experience is. And really, why is this important? Because in reality, many organizations have what's called the wall of confusion, and it often leads to a very high friction environment. There could be sure feedback loops that get cut across because we don't know who the responsibility lies in. There might also be the debugging loop might be broken, so you might be able to debug it and deploy it in your local environments, but as soon as you actually get into test, you can't do certain things. Devs don't have access to the cloud portal, for example, even for dev and test environments, and fixing these issues could take days or weeks even. One of the organizations that I worked in, we had no visibility on the effect of any of the changes that I did as a developer. And I had to just raise a ticket to go and ask someone to look at it and find out a week later whether there were things that I'd actually broken or fixed. And once I raised the ticket, there's a lot of waiting, and then you wait even more. And I couldn't use any of my existing skills, knowledge that I know that I have, and it just led to a tremendous amount of frustration. And I've got all these tools at them, but very limited access to actually do anything meaningful. And really, this has a huge impact, and we're seeing this across the industry now that's catching up to it. There's a recent paper on Martin Fowler's website by Tim Cocker on developer effectiveness, which really highlighted, for an effective environment, you need those feedback loops to be fairly small. And if you don't have them, for example, in this case, validating just whether things are working in governance or deploying and ensuring things in working in production, the lead times could be really long. All the red bars here are effectively, it's where dev are spending more and more of their time. So time that's spent waiting effectively, time spent, using cloud resources, and also that's time spent just developers making coffee as a result. And really, what this then brings us to is ultimately developers are quite smart. They're going to find workarounds if you put roadblocks in front of them. So it's really about developer experience is really about making it easier for developers to try and do the right thing, but safely. And if you don't do that, like I said, they will find workarounds, and later in, it'll be that you might realize there's kind of hacks into production, for example, which we've seen on many of in many cases. And overall, this could have even a more dreading effect on the entire organization, because you might end up with dysfunctional and demotivated teams. You might get developers who are burnt out. As an organization, you might struggle to retain the best developers that you have because another competitor is offering all of these capabilities. Could lead to toxic culture, low levels of productivity, backlog sort of just increasing in terms of size. Your technical debt could be going up. Delivery of features keep pushing out. The next, we'll do it next release kind of mantra comes in. Ultimately, this is a large financial cost to enterprises when there is simple things that you can do to really unlock yourselves and get out of this challenge that is that can be solved by developer experience.
Yeah, so let's look at a couple of a few factors that create a good developer experience. First off, it's important to understand the boundaries and the interactions that the developer has with the rest of the platform and the rest of the organization. A platform has layers, and this is quite understanding these layers is early on is quite important. So the bottommost layer, a platform layer, exists to enable all the product teams building on it, and the product teams enable users, and users in turn enable the organization to achieve its goal. So the bottom layers always enable the layer above it. And it's also important to understand the boundaries between these layers. The platform is a curated experience for engineers to accelerate the delivery teams that use it. And it's built around the thinnest set of guidance, APIs, documentation, and config. The platform is a governed and safe space of product delivery, and the platform team owns the risk and governance for shared components like VPNs, CI/CD tooling, central identity management, and they own the risk and the governance process for those platform components. Most of all, the platform team exists to enable product teams to deliver fast. And this is a boundary that you have to be aware of. The product-focused team build and own and run their products. They own the product governance. They don't own the governance around any of the shared components. They own the product risk. The platform team and the platform don't own any of the risk associated with the product. The product team should own the end-to-end delivery. Doesn't matter how many environments they transition to, that's up to the product team. They can go from dev to prod, or they can have any environments in between as they want. And the product team owns the billing and financial risk. Team interactions impact all these boundaries. Every team in the organization exists to help product teams, because product teams are the tip of the spear. They are the function that builds stuff that brings value to the organization. So So all the security, governance, architecture, and agile coaching teams all exist to help these teams succeed. Um, this is shown here using the team topologies model of facilitating team and the platform team's interactions with the product team. Early on, to help with these boundaries and layers, it's important to build your shared responsibility model. From day one, the developer experience depends on developers understanding what they can do and what they can't do, and what they're responsible for and what they are not responsible for. So you've seen the shared responsibility model from many cloud providers, and it's quite important for you to build your own internal shared responsibility models. Like what is a product team getting? Um, what should they care about? So taking those layers, boundaries, and the shared responsibility model, this is an example using the Azure Cloud Adoption Framework architecture to show you what's the size of the playing field for the dev teams and the platform teams. So if you look at the blue parts, that's the platform team responsibility. So there's quite a lot of things that the platform team needs to be responsible for. And if you look at the green bits, that's the product team responsibility. So you can see that this good developer experience is in a tightly controlled space. It's not a wild west. It's not developers running and across all over the landscape and changing things. And understanding these boundaries, the constraints space that developers play in, helps you to constrain the developer experience and make that constrained developer experience awesome. So to help get started with the developer experience, enable continuous delivery by default. This is a core engineering practice that helps to scale cloud adoption and give a good developer experience. So to get to continuous delivery, one of the tricks I like to use is to build a working skeleton. And this is the first thing I build and deploy. It's a simple system. It's a tiny implementation of the system that performs a small end-to-end function. Doesn't need to use the final architecture, but it should link together the main architectural components so that the architecture can start to evolve. So what I do is I take the system and try to deploy it all the way to a production environment. Take it through all the environments the organization has. And don't bother building any other functionality until this is in prod. It's got no usable functionality, so it should have very little risk. It should be easy, right? So deploying this walking skeleton helps you to explore all the roadblocks that your organization has on the path to production. So if it's really hard and there's a lot of friction in deploying a very simple system, it's going to be very hard. There'll be more friction deploying anything more complex. So deploying the walking skeleton helps you validate the developer experience and test what it's actually like. And we do that because only prod matters. You only get accurate feedback when actual users use the software you built. Everything before that has questionable value. Can you test in production? If you can, do so. Leverage canary deploys, feature switching, rolling releases, monitoring, and synthetic transactions to help achieve this. Most importantly, learn to differentiate between deployment and release. Deployment is the installation of a new version, and a release is getting the new version out to your users. Differentiating between those two gives you a lot of leeway to figure to release your system to production. So the only environment that should be permanent is prod. Everything else should be temporary. So to get this right, pay attention to the time spent onboarding, time spent waiting between transitions to environments, cycle times, number of times a team has to interact with another team. So a good developer experience, it's just not about what happens on the developer desktop. It's the whole journey of a developer getting what they've built out to a production environment and into the hands of users. And then pay attention to feedback loops. Feedback loops are things we should focus on. If we are doing continuous delivery and using pipelines, our pipelines are full of signals. We live in feedback loops whether we like it or not. We can choose to act on them or ignore them at our peril. And by not listening to these feedback loops, by not listening to the difficulties we have with our pipeline, the wait times, the slowness, things breaking, the interactions we need to have with other people, we lose users. And if we lose users, we lose market share, business value, and so on. And the simple feedback loop is conversation. A dev can have with the user. Devs enjoy building stuff and showing them to users. All our complicated processes don't matter if we fail to have this conversation. All what we do exists to provide a service, to make someone happy, and eventually get some business value out of it, or make more money out of it. Shorter feedback loops and a good developer experience help us connect with the user. So the developer experience shouldn't really focus on fast deployment. It should find a way to get faster feedback. It's important to keep that conversation going. And that's what a good developer experience brings to the table. It helps the developer have that continuous, sustained conversation with the user. Do you like what I built for you? Get some feedback. Is it broken or is it awesome? If it's awesome, let's build something more awesome. Yeah, over to you, Richard.
Yeah, thanks, Hibri. So one of the other bits that I also wanted to talk about was enabling discovery, visibility, and self-service. And what that means is effectively, if you go on to the next slide, please, there, Hibri, is about giving developers visibility, right? And this is really crucial to unlocking a lot of where the bottlenecks could arise. As a developer working in a cross-functional team, I want to have full visibility, right? I don't want to be locked out of cloud portals. I want to be able to have access to sandboxes, that I can play around safely. Hopefully get read-only access to production environments, getting access to metrics, alerts, and non-sensitive logs, allowing my team to make their own dashboards effectively. And these are all, giving the developers visibility onto the entire SDLC across the organization is really a crucial element that you can use to unlock some of these problems. And really, the kind of the idea here is to not lock them out. And one way of really kicking that off is, leveraging RBAC, for example. A lot of times, we see this myth buster all the time that, from a security standpoint, we can't give devs access to production instances. Well, actually, you know what? You can. If you use RBAC in cloud properly, you can safely give read-only access to production. And ultimately, it's better to have some sight of what's going on in production than be completely blindsided when issues or events do occur. And if you don't have this in place, then again, you stick to your old, raise a ticket, go to some central team for them to look at the log, for that log to come back only with inefficient, not enough detail in it, and so on and so forth. And the time that's spent in just diagnosing or debugging is just increased. And as Hibri mentioned, the feedback loop just keeps going. And the time that takes, it just keeps going up and up. And And ultimately, if we can use RBAC rightly, then why not allow developers to use the CSP's portal natively? Do we really need another layer on top, that a self-service portal, when developers can just, they work in other organizations or do training courses, but they're learning to use AWS, GCP, Azure portals. Why not give them access directly to these portals in a safe manner? And this then comes down to choosing tools that leverage existing knowledge that developers have, and tapping into or contributing to existing ecosystems, and also being really conscious of building anything that's custom built, because there's always a learning curve for developers to understand that. The more you can use, off-the-shelf or open source technologies to enable some of these for developers, the easier it's going to be in terms of adoption and feedback points. And this then comes to our final point really on, so how do we scale cloud adoption and developer experience? And that takes me to, what makes a good developer experience? Just the next slide there, please. Yeah, thank you. Yes, what makes a good developer experience? So good developer experience really is all about reducing the friction in using cloud, and potentially across the entire route to live. And in that context, and it's specifically in the context of your organization. It encourages, what happened there? Sorry, previous slide still. Thank you. Yeah, it encourages exploration of cloud features. So, you're able to, within a good developer experience, the developer's able to kind of explore what's available in terms of the cloud features. Developers can bring, what they learn outside, but they can bring it into the organization. And there's always a safe, fast path to deliver real business value for the end customers, and getting sight of that end customer to the developer is also part of a good developer experience. And here's a few kind of, the important bits to take away from all of this really is enabling the developers, adding in guardrails so that they can do things safely and not adding in roadblocks. For example, putting in CI/CD is a great example of getting those shorter, faster feedback loops. Having a safe innovation space that we talked about, trial things out, fail fast so they can recover quickly. Other tricks are around QE strategy, in terms of quality engineering. What is the testing strategy? Where does the test pyramid fit in terms of our development practices? And it's not just across the application, but also across the infrastructure layer. And having a focus on automation and testing, so more and more of that can shift left. Enabling a culture of communities of practice, so there's a culture of learning and continuous improvement, is another great enabler that you can have in the organization to adopt developer experience and engage with developers. And the best way to do any of these initiatives is by starting small. The State of DevOps 2019 report, one of the things that was found across the industry in terms of methodology that worked the best is really the templating methodology. Figuring out what a good QE strategy looks like with a small bunch of teams or a community, and then really implementing it and creating almost a North Star for all of these underlying capabilities that can then enable the transformation to happen. And these are some of the things that you really need to take away from this deck in terms of, how to enable that in an enterprise environment for your development teams.
So a good developer experience, what it does is when you get that right, it creates an environment of psychological safety. You release the developer from having all these anxieties about, are they doing the right thing? Are they talking to the right people? What happens when they make mistakes? If you take that all away and give them good dev experience and create that psychological safety, you help developers and development teams to be their best selves. And when they are their best selves and they learn, and that creates new ideas and creates innovation. And it's also for a developer not to worry about all of the things that could go wrong and all the things they have to do. If that's all built in by default, it reduces the cognitive load for the team. The team can actually focus on creating business value. Thanks for listening to our talk. Let us know if you have any questions. We'll watch the chat. Thank you.